Okay. All right, okay, we're going to do chapter 5. Okay. Okay. And you can look along in the book as we go if you want to. Chapter 5 is on number theory and the real number system. And the first thing that we're going to talk about is a chart of numbers. Okay. And on this chart, you will need to be able to draw this chart on the next test. We have some different numbers, and we're going to have a big rectangle here that we're going to put these numbers in. And in the very center, we're going to put an N, which stands for the natural numbers. And the natural numbers are the counting numbers. It's natural to count with 1, 2, 3, and so on. So natural numbers are the counting numbers. Then we're going to draw another circle here, and we're going to add a 0 to the natural numbers. So it's 0, 1, 2, 3, and so on. So these are the whole numbers. 0, 1, 2, 3. Natural is 1, 2, 3, and so on. Natural whole integers. Bobby said earlier that the integers, you add the negative numbers. Okay, so the integers, you're just adding the negatives. So put a couple of negative numbers here, the 0 and 1, 2, and 3 for the integers. Natural whole integers. Next is rational. The R is rational. I guess I needed to write down integers on these. The rational numbers are the fractions and the decimals. Fractions and decimal numbers. So you might have 0, 1/2, 1, 1.3, 2, 3, and so on. And also, they're like negatives too. Okay. So the rational numbers, you're adding the fractions and decimals. Okay, so natural whole integers, rationals. The next thing is the real numbers, which are all of these numbers in this big rectangle. Okay, the real numbers, or all of them. And then over to the side somewhere, we have the irrational numbers. The irrational numbers are like pi, square root of 2. Pi and square root of 2. Okay. Now, these are things that neither end nor repeat. Okay. The pi, the irrational numbers, they will never end and they will never repeat. So, natural whole integers, rationals, reals, and then over to the side over here are the irrational numbers. Now, from what you know about Venn diagrams, these things do not intersect, do they? Okay, it can't be irrational and rational. It can't be irrational and a natural number. But all of them are real because they're all inside this big
universe
box here, right? But if
So the only thing that makes the only difference between the real number and the rational numbers are the irrational numbers.
Right. these are irrational. These are rational right here. They're fractions, decimals, things that repeat, and then just plain old numbers. Okay. So rationals, you add the fractions and the decimals to it. Now the best way to learn this is go natural, whole, integers, rationals, reals, and then stick the irrationals over here. Natural, whole, integers, rationals, reals, irrationals. Natural numbers are the counting numbers. It's natural to count with 1, 2, 3. Whole numbers, add the O, the 0. Whole numbers, add the O. Integers, add the negatives. Rational, add the fractions and the decimals. Irrational, add pi, radical 2, things that neither end nor repeat. Neither end nor repeat. If it's like 0.3 with a bar, see that repeats. Okay, so it is a rational number. Okay. But you'll need to be able to draw this particular chart on the next test. Now, if you look on page 250, there's also a chart there, but they use all rectangles on it. And I've always done mine with circles.
That's funny because I've always seen it with the rectangles and the circles.
Right, because it doesn't matter which way you do it. Okay, so you have your natural, 1, 2, 3. The whole, you add the whole thing, the 0. The integers, you add the negatives. The rationals, you add your fractions and your decimals. And then over there to the side are the things that neither end nor repeat.
I'm having, my brain is having a hard time understanding either end nor repeat.
Okay.
You gotta just think repetition, repetition.
We're going to show you that in just a minute. Okay, when we get to it. Okay, if you have something like, get your calculator and look up the square root of 2. Alright, square root of 2, you put in 2, and then you do the second button and square root. So it's 1.4142135562, and so on and so on and so on. It never ends and it never repeats. You can do the pi button, which is on mine, it's right here. I can do second and pi, 3.1459264, and it will keep on going forever. People, when they first got computers, they would try to program a computer and put pi in there and see when it would quit. And it wouldn't quit. It just kept going for days and days and days. Okay.
I'm just having trouble. Like, how does it not eventually repeat itself?
It just won't.
Okay.
That pi is if you take like the diameter, let's see, the circumference divided by the diameter. If you any circle, you can take this and divide it by that, and it will always come out to 3.14.
It's in a different place value. So even if it's, what was confusing me is like there's only like 1 through 9, you know, but it's in a different place value, so it's technically like a different fraction. Or
It's all fractions or decimals or whatever. Okay. But every single circle will give you 3.14 blah 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 blah.
Yeah.
If you take this and divide it by that. And when I teach middle school, we bring all kinds of lids, plates, and everything else, and tape measure go around to prove that it really doesn't. You know. Okay. Now another term that we use is prime number. A prime number is a number that is only divisible, evenly divisible, by itself and 1. Only divisible evenly by itself and 1. And if I say like 2, okay, you can divide 2, we're going to 2 one time. Alright, 3. 2 won't go into it, 3 will go into it one time. 4, Okay, see, 4 is not prime because 2 will go into it, so it's not prime. Okay, 5 is prime. Okay, 7, anything go into 7 besides itself and 1? 8, not prime because 2 and 4 will go into it. Okay, 9,
No.
9, okay, because 3 will go into it. 10,
No.
no, 5 and 2. 11,
Yes.
yes, okay. So these are the prime numbers. The other ones are called composite. Okay, that's the rest of them. Okay, it's not prime. We'll just say it's not prime. Now, on page, say 209, I think it is, there's something called the seed of Eratosthenes. And somebody, Eratosthenes way back there in 275 to 195 BC figured out how to find all the prime numbers by using this particular thing. Okay, anyway, so we have prime and we have composite, and the number 1 is neither. It's neither prime nor composite. Okay, now if you want to determine if a number is prime, you can divide it by the prime numbers. Okay, to determine if a number is prime, divide it by, let's see, 2, 3, 5, 7, 11, 13, etc. And we're going to use something called a factor tree to put things down to their prime factors. I'll explain what this means in a minute. We're going to use a factor tree. Now, they call it something else. Let's see, on page 211, they call it branching. But it's the exact same thing. It's a factor tree. Okay, now, so we're going to take a number like 10. You did this in your head a while ago. You knew that 2 and 5 would go into it. But we're going to write it so that when we get through, we have the prime factors of this. If we take the smallest prime number, which is a 2, divide it into 10, it goes 5 times. Both of these are prime, so that's your answer, 2 times 5. Okay, if you have 15, what's the smallest prime that'll go into it? 3 and 5. So that's your prime factors right here. If we have a 17, we try 2 into it, 3, 5, 7, 11. Okay, so it is, okay, it's just a prime number, so you can't write its prime factors. It's prime. If you have something like a 91, now that looks like it might be prime, but you have to try them all. Try 2, that won't work. What about a 3? Okay, a 5. Okay, a 7.
Yeah.
Okay, so 7 times 3 is 21. So see, you look at it and you think that's prime, but you got to try them to make sure. You can use your calculator, whatever. Okay, now so that's the prime factors of that. If you want to try 60, okay, 2 times 30. Then we'd have to break 30 down. 2 times 15. So we got a prime, and a prime. Now, a better way to write 2 times 2 times 15, well, we'd have to do 15 into 3 times 5, sorry. Okay. I always put them in order, 2 times 2 times 3 times 5. Okay, smallest to largest. It's not wrong if it's the other way, but it's easier to check in the back of the book, you know, if you've got it right or not. Now, there is a better way to write 2 times 2. We could write that as 2 squared times 3 times 5. Or in other words, you've got 2 of these 2's. Okay, 3 times 5. So in a factor tree, if you're trying to find the prime factors, you get it down to the bottom, and then you put them in order, smallest to largest. If I've got like a 3 times a 3 times a 3, that's a 3 to the 3rd. If I've got 4 of them, that's 3 to the 4th. Okay, so you get the idea on that. Now, you might see another way to do it, and I want to show you this one. If you have to find the prime factors. Okay. All right, let's say we had a 36. Now, some people might say 2 times what? 18? Is that right? Others might say 6 times 6. Okay? I would probably see that first, and then I would do 2 times 3 and 2 times 3. So I've got 2 times 2 times 3 times 3. Okay? So I've got 2 2's and 2 3's. But if you started out with the smallest prime like you're supposed to, then that one's prime, 2 times 9, that one's prime, and 3 times 3. You see how you end up with the same thing? 2 times 2 times 3 times 3. I still end up. It just depends on the way that you see it, best. Okay. This is actually the proper way to do it because it automatically ends up being in order, But sometimes you can't see it.
So there is a particular order you need to put it in.
Just put them in smaller to larger. It's just easier to check. Okay, let's say we have a 72. Now, how would some people do that?
36,
9 times 8.
36 times 2 or 9 times 8. Okay, I'm going to do it both ways. Okay, 2 times 36. 36. If I did 2 times, what? 18? 18, 2 times 9. 9, 3 times 3. 1, 2, 3 2's. Times 3 squared. Okay. I probably would not do that. I'm just being honest with you. I would do 9 times 8. And I would do 3 times 3. And I would do 2 times 4. And then I'd do 2 times 2. And I've got 3 2's and 2 3's.
So the smallest
ends up
number,
the same thing.
The smallest number you can come up with is probably the best then.
This is the proper way to do it. By taking your smallest prime, And when you get a prime, most people usually circle them. Okay. But when I see 72, my brain says 9 times 8. And so then I just break it down. It doesn't matter, which way you do it. Okay, you try this one. 216. Do it any way you want to do it.
So if I was to do 216, I would tree down to 2 times 108, and then go from 108 down. What that can be divided into until I can't do it no more.
That's what I'm understanding.
Yeah, that's what I thought too. This is some tricky stuff right here.
I think that have it, but it looks weird.
Okay, get something?
Yeah, but I'm afraid to say
Okay. All right. 2 times 108. 108, 2 times, what, 54? 6 times 9, I just saw it that way. So I've got 3 2's and 3 3's. Is that what you got? I hope.
I got 3 2s
Uh
and 2 3s.
oh. Okay.
No. I got 3 3s, but I got 3 2s.
Okay. Well, that's right.
I did?
Uh-huh.
I thought you had 2 2s.
3, 3, and 3. Okay, Joey needs help. If y'all will go help him, then we'll come back and finish. Just a minute.
Your
An
son?
auditorium.
Your son?
Uh-huh.
Okay.
Yeah, a break from the hard stuff.
Right. Next tables. I don't know whether we ought to get them out of here.
lessons and we're done.
Hon, did you know we're done with our English?
I don't know.
Maverick told me we're done, no more.
Really?
Yeah, he says, yeah, that's what he goes, I promise you, we're done. I was like, for the whole semester, he goes, yeah. I was like, no!
Yeah, there's no way. That's
I love that.
Was it really heavy?
No, not at all.
no, but yeah, but just 3 lessons and then that's it.
That would be stupid.
Yeah, it's unbelievable.
I'd be like, I want a refund.
yeah. Is that true? He said that. Is it done?
I don't know. No clue.
Maybe the teacher is on vacation.
I don't know. I mean, I can never get a hold of her by text, phone call, email. You know, she teaches at Martinsville and she teaches another class here at night.
Who's that?
My sister Faust. Sister Faust.
Faust. Oh, okay.
But it's been 2 weeks now.
Yeah.
Hmm.
And if he says we're done, I'm like, there's no way we're done. She would have told us. Hey, you're done.
All right, the next thing we're doing, what time is it?
10 o'clock.
Okay, good. All right, next thing is comparing integers. Thank y'all so much for helping to do that. That saved Joey quite a few steps. He's leaving. He and Jeremy both are leaving tomorrow for various places. Okay, now when you're comparing integers, if you have like a 5 and a 0, you naturally know that 5 is bigger than 0, okay? Because you just know that. But if you have something like a -7 and a -2, sometimes that gets a little confusing. But if you think about where these are on a number line, like here's 0, -1, -2, 3, 4, 5, 6, 7. Okay, here's -7, here's -2. -7 is less than -2. Okay, it's further to the left or it's a smaller number, so it's less than -2. Also, if you think about it as being on a number line, I mean like a thermometer, you know that the positives are up here and the negatives are down here. So if you have to compare like a -2 and a 1, -2 is less than a 1, so -2 is less than 1. Or you can say 1 is greater than -2. Alright, so you might have to compare different numbers and put greater than or less than. Okay, if you have something like -3 and -4 and you had a blank in there. Okay, greater than or less than?
It would
Greater than. Okay, so if you think about where they are on the number line, here's a -3, here's a -4. So this one's the biggest. -3 is greater than -4. So sometimes you have to think about that. Next thing is like adding integers. Sometimes they call these signed numbers because they have little positives and negatives on them. If you have like a 2 plus a 3, you just add it and it's a 5. If you have a -2 plus a -3, you get a -5. If you think of a number line, okay, here's -2. If you go down -2, then you go down 3 more, where are you? You're down here at -5. Now, back in, well, now they do it in elementary, but it used to be, when you're in like middle school, you would learn how to add these signed numbers. But if you have something like a -5 plus a 2, okay, if you think about a number line, go down 5 and then back up 2. So you're at -3. By now, all of you have figured out how to do this in your head. You would never get out your calculator and go, like 3 negative plus 5 equals, you just wouldn't do that.
Depends on what time of the day it is.
Yeah, right. Okay, but anyway, so there are rules for these. If you're adding integers, a positive number plus a positive number is a positive. A negative plus a negative is a negative. That's like these first two. But if you have a positive plus a negative, one of the things that you do is just cover up the signs and subtract them. You get a 3. Take the sign of the bigger number, so it's a negative 3. Okay, you subtract and take the sign of the larger number. Okay, let me move this up. Okay, so positive plus positive is positive, negative plus negative is negative, positive plus a negative. You're covering up the signs and just looking at the base number or the absolute value of it. So 2 from 5 is 3. 5 is a bigger number, so it's a negative. You can also think about it on the number line or however you want to do it. But anyway, that's a rule for adding integers. Now, if you have another thing to think about is like when you're playing football. If this is a line of scrimmage and you gain 4 yards on one play and then you lose 6 the next time, where are you? Okay, here's the line. You gained 4, 1, 2, 3, 4, but then you lost 1, 2, 3, 4, 5, 6. So you're down here at -2. Okay. Now, for some people, that's easier, to think about, gaining and losing like on a football field. To others, it makes no sense whatsoever. Okay. All right. And so if it doesn't, a positive plus a negative, you subtract. 4 from 6 is 2. Take the sign of the bigger number, -2. Now, the next rules are subtraction. Okay. Now, subtraction in any shape or form always is a problem. Okay, I don't know why, it just is. Okay, so the first examples of subtraction, if you have like a -3 minus 5. Okay, you can think of being on the football field. You lose 3 and then you lose 5, so where are you?
-8.
-8. Okay, if you have 5 minus 2, that's just a regular subtraction problem. 3. If you have a -3 minus a -2, okay, think of this as a double negative, which makes it a positive. So now, you go back 3 and up 2, where are you?
-1.
-1. Subtract 2 from 3, take the sign larger number, -1. Okay, if you have a -8 minus a -3, change sign second number and add -5, or in other words, double negative. Okay, -5 minus 2, down 5, down 2 more, -7. A -4 minus a -2. Okay, where are you now?
-2.
-2. Okay, so hopefully you have figured out how to do this. Now, your rule on these things is to change the sign of the second number and add, or in other words, go back to your adding rules. Okay, so if I change the sign of the second number and added, -3 plus -5 is -8. If I change the sign of the second number and added a positive plus a negative, subtract, take a sign larger number. We did that, -7, and we did on that one. But like I said, subtraction is a problem no matter how you do it. Okay. Now, next thing we do is the order of operations. Okay. Order of operations. I'm sure you remember this. How many of you have had algebra?
forever ago, but yes.
How many of us remember it?
Okay, right. That's a different question, but at least if you've had it.
Maybe it'll come back quicker. Yeah.
Right. Okay, you may remember the order of operations. Please excuse my dear Aunt Sally. Anyone else have another way that you remembered that? Okay, the P stands for parentheses. In other words, do the innermost grouping symbol first. Okay, always do the innermost grouping symbol first. E stands for exponents. After you have done the innermost grouping symbol, then if it has any exponents in it, you do that. M and D is multiplication or division, whichever one comes first from left to right. Okay, multiplication or division is my dear Aunt Sally, is addition or subtraction, whichever one comes first from left to right. And then I'm going to show you some problems so you can refresh your memory on how to do this. But this is called the order of operations. Now you have a 3 plus a negative 2 plus 7. Okay. You look at this and your instructions are to simplify, which make it simpler than it is right now. Okay, so parentheses, yes, we've got parentheses, so we've got to do that part. So what is negative 2 plus 7? 5. And we've done that, so there's no multiplication, there's no division, there's no exponents or anything. We come down the adding and subtracting, so 5 plus 3 is 8. Okay, so that's simplifying that. If we have one like this, 3 squared plus 5 minus a negative 2. Okay, now, what are we going to do first?
5 minus the negative 2.
All right, so we have 3 squared plus 5 minus a negative 2, which is a 7. Now what do we do?
The exponent.
All right, 3 squared is 9 plus 7 is 16. Most of the time, these will make a triangle or a pizza, depending on whether you're hungry or not. Okay.
Always.
Right. Okay. So, let's see. Now, what we're doing today is just 5-1 and 5-2. So you can look at 5-1. We're skipping greatest common factor and least common multiple and all that kind of stuff. Okay, 5-2 is on adding and subtracting. Okay. And let's look on page 226. Just a minute. On 226. And it says, evaluate these expressions. Let's look at number 13. Okay. It has this and this. Okay, there's number 13, and it looks terrible. It's all long, but if you do go through your order of operations, it's not bad. See, inside your parentheses, you have a negative 3 plus a negative 4, which is a
7,
negative 7. Okay, plus 9. So we did everything in the parentheses. Multiplication, anything else. So what's negative 7 plus 9? 2. Okay, notice how it turned out like that. Okay, look at number 14. We have an 8 plus a negative 3, brackets plus a negative 2. Okay, what do we do first?
Negative, 5.
Okay, 5 there. 3. Okay. All right, let's suppose we had one like this. This is number 36 on page 226. Now, if you don't use your order of operations, you'll end up with a totally different answer, you know. Okay, so somebody sometime or other way back when figured out, you know, the order. And so they've been telling everybody else since then how to do it. And you get the right answer, so it works. Okay, what do we do first?
-8 times 4.
Good, okay, and that is a negative
Or negative
32. Now,
Why is it negative?
minus what?
Because you're multiplying it down the scale rather than up the scale, so it would be still a negative number then.
Yeah.
Okay.
Right, well, I forgot, that's one thing, they haven't, oh, I don't know if we've had multiplying and dividing yet in this. Okay, I better give you the rules for multiplying and dividing. I don't know where they are. It was, okay, alright, I had done something different. Okay, let me take a break right here and give you the rules for multiplication and division.
I'm sorry.
No, I'm glad you did that. Because that's what I was thinking. Oh, we hadn't had that yet. Okay, your rules for multiplication and division. If you have like signs, the answer will be a positive. If you have unlike signs, your answer will be a negative. Now, you think, what in the world does that mean? All right, if you have a positive 5 times a positive 3, you get a positive 15. The signs were alike. If they are unlike, negative 2 times 7. This one's a negative, that one's positive, so they're unlike. So your answer is a negative 14. So if they're alike, it's positive, unlike, it's negative. And that makes sense. You've got 7 negative 2's. So that's going to be a negative. And here you've got 3 5's. And notice I'm using a dot instead of a multiplication symbol now because we're getting into algebra.
Up for game.
And
And
the
it's-
X,
yes.
the X is going to be a exponent, right?
The X is going to be a variable. It will stand for different things and different problems. Okay. Now, so let's go back and finish that problem now that we have that part. Okay. So that's why a negative 8 times a 4, they were unlike signs, it was a negative. Now we're still in this one. So 5 times negative 32, positive or negative answer? Negative. 160, okay. And then we still have this right here. Whenever you have two symbols beside each other, that means multiply. Okay. So,
So it'd be positive.
Good.
320.
good. Notice. Okay. Most of the time, I get my sign first. Why would I do that?
Just to clarify, I guess.
So I won't forget it. Because I get busy multiplying and then I forget, my sign. Okay.
Big
Now.
pizza.
Right. Okay. Now, suppose I have something like this. A 2 out beside a 6. What does that mean to do? Multiply. Okay. So if you've got symbols next to each other, it means multiply. If you've got a number beside a symbol, it means to multiply. Always remember to do your innermost
What are the
parentheses.
difference between the brackets and the parentheses?
Nothing. It's just if you put parentheses inside of parentheses, it gets confusing. So it's just do what's in here and then do what's
Okay.
there.
I got you.
So
Okay.
the innermost parentheses.
And you can even have braces,
Oh, goodness.
so they just add different things to make it go bigger and bigger. Okay, now we're going to try these. Let's see. I'm not sure. Okay, we're not doing the one that's marked out, which makes sense. Okay, so we're going to list prime numbers, we're going to use factor trees, then we're going to evaluate. And then we got a ton of pages of add, subtraction, multiplying, and dividing. Okay, do pages 1 through 5. So this will be the last page that you do. This one right here. Okay, and then we'll wait on the other till next week.
Can we do this now, or if we don't?
About what time is it? Yeah, start on it.
Yeah. Yeah, so 10:20.
No, do through page 6. Through page 6. Page 1 through 6.
1 through 6?
Uh-huh.
1 through 6.
1 through 6.
I'm sorry.
I changed my mind.
1 and 6.
Okay, 1 through 6. And I have they have all sorts of different numbers on them, but they're like, up there like that. Most of these won't take long. Okay. 1 through 6.
Just a reminders before I forget. I think it's 3 weeks from today. I won't be here physically. But I'll watch whatever video.
Okay, that'll be fine. I'm sure you'll be watching a whole lot.
Yeah. Yeah.
Eventually you will. Catch up. So that's on the 17th, right?
Yes, ma'am.
I actually had it still down here.
Okay.